So question 8 says, find the domain of the function. So we have f of x equals the log of x to the fourth base 8. So remember what we're taking the log of. This part right here has to be a positive value. It's got to be greater than 0. So what I can do is what I'm taking the log of, which is x to the fourth, must be greater than 0. Well, if I look at that, the only thing that's going to make a 0 is 0. So x cannot equal 0. But notice that if you put a negative number in here, any negative number raised to the fourth power is going to be positive. Any positive number raised to the fourth power is going to be positive as well. So every other number is going to be greater than 0. I just can't use 0 itself. So my domain is really going to be everything but 0. So since they want interval notation, we can say then negative infinity to 0 in union with 0 to infinity. So those would be our two intervals for that. If I want to look at the graph of this, so if we type in y equals the log of 8, so I need to use the special one here. So we hit the math button. Instead of going down arrow, I hit up arrow and choose this log base, hit enter. So the base is 8 actually. And we have x to the fourth power. So x to the power of 4. So if I look at the table, notice that if you put 0 in, notice that you don't get a y value out. That's an error. But notice that if you go negative or positive, you're seeing output values, which means to be a function, every x value has to be associated with a y value. The only one that's not is 0. So we can kind of see it with respect to the table on that. Now, if I look at 8b, notice how we have x to the fifth. So this x to the fifth has to be greater than 0. Notice that if you raise a negative number to an odd power, it's still going to be negative. So here, x is still going to have to be greater than 0. Because if you put a negative number in, it's going to be negative, and a negative number is not greater than 0, and 0 is not greater than 0. So in this one, our domain would actually be from 0 to infinity. So if I look at my graph or my table, if you will, so if I have y equals, if I change this exponent to a 5, that looks good. If I go back to the table, notice that 0, oops, go back to the table. Notice that 0 would be an error, and notice that all negative numbers are errors. So remember, that means I'm not associating a y value with the x value, and that's called a domain restriction. But notice that once you get past 0, you're starting to see output values or y values being located there. So that kind of can verify it there by looking at the table as well. Again, if you look at the graph, you kind of see that the domain is from left to right. Notice that the y-axis is a boundary line. That means x is equal to 0 as a boundary line. So you are right of the x-axis. In other words, you're right of 0. So that does make sense that my domain is 0 to infinity. So notice that an odd exponent will create a different domain than an even exponent on the inside, because the even exponent will still make whatever x is, will make it positive, and you can take the log of a positive value.